beginning our review video of section 4.3. That's chapter 4, section 3. And as always, we start with our learning target for the day, our goal for the day. We're going to find rates of change. We're going to find out about rates of change. Well, let's define what rate of change is. And here's its definition. A rate that describes how one quantity changes in relationship to another is called its rate of change. So let's jump right in and do a problem here. Table below shows the weight of a dog in pounds between 4 and 12 months old. Use the information in the table to find the rate of change of a dog's weight between 8 and 12 months of age. Well, if I look at this, at 4 months, this should be months, 4 months, the dog's weight was 15 pounds. At 8 months, the dog weighed 28 pounds, and at 12 months, the dog weighed 43 pounds. Well, they're asking me to calculate the rate of change between 8 months and 12 months. So first of all, I have to find the difference. How much did the dog grow? Well, if you look at this, the dog grew 43 at the end. It started at 28. So 43 minus 28 would be its increase in weight. And of course, it did that in from 12 months to 8 months. So 43 minus 28 is 5 pounds. And 12 minus 4 would be 4 months. 5 pounds in 4 months. To write that as a decimal, that's 1.2 pounds per month. All right, so that's its rate of change, its average rate of growth. The table below shows Julia's height in inches between the age of 6 and 11. Find the rate of change in her height between the ages of 6 and 11. Well, here's the table. At age 6, she was 52 inches tall. At age 9, she was 58 inches tall. And at age 11, she was 60 inches tall. The rate of change between ages 6 and 9. What, at 9, she was 58 inches tall. At age 6, she was 52 inches tall. So that shows the change in height, and the change in years would be 9 minus 6. So 58 minus 52 shows a 6-inch increase in 9 minus 6, or 3 years. 6-inch increase in 3 years, I need to reduce that. I'll divide 3 into both the numerator and into the denominator, and I get that is a 2-inch increase per year. 2-inch increase per year on average. The table shows the number of students in the 8th grade between 2000 and 2004. Find the rate of change between 2002 and 2004. Well, 2002 and 2004, look at these two numbers. The number of students actually went down. It went down. At the end of the time period, it was 459. At the start of the time period, it was 485. And of course, 2 years passed. 2 years passed from 2004, or 2002 to 2004, 2 years passed. So 485 subtracted from 459 shows that it went down. The number of students went down by 26 students. 26 students. It actually went down by 26 students in 2 years, or that's a negative change of 13 students per year. 13 students per year, and notice the negative, indicating that it's reducing, it's going down. The table below shows the number of students in 6th grade between 1999 and 2005. Find the rate of change between 2003 and 2005. Well, 2003, there was 339 2005, there was 301. So 301 minus 339 indicates a negative or a drop of 38 students in 2 years. 2 years. So I reduce that here and I say negative 38 divided by 2 is 19 students, a negative 19 students per year is what the drop is, the drop in students. Another way to look at this, another problem. We have the graph, we were asked to graph the data below. So I'm going to graph 54 at 10 o'clock. So 54 degrees was the temperature at 10 o'clock. So I put my dot here on the page. 55 at 11 o'clock. So it'll be about right here. 59 at 12 o'clock. 59 at 12. All right. And 60 at 1 o'clock. All right. And then 60 again at 2 o'clock. And 62 at 3 o'clock. All right, would be a graph that looks something like that. During which 1 hour time period was the rate of change in temperature the greatest? So working out this question, I can do it from the graph, or I can go back to the table and I can say during 1 hour, which 1 hour time period was the rate of change in temperature the greatest? Well, the temperature change from here to here was 1 degree. From here to here was 4 degrees. From here to here was 1 degree. From here to here was 0. And here to here was 2. So the rate of change per 1 hour, and each of these are 1 hour in increments, the greatest time period was from 11 to 12 o'clock. It went up by 4 degrees. If you look at the graph, that does happen to be when the graph is at its steepest. When the graph is at its steepest. Here's our summary statements that we want to put on our rule cards. Concept summary, rate of change. If the rate of change is positive, it slopes upward. The graph would slope upward. If the rate of change is negative, it shows it's decreasing and it would drop down. The slope would be negative.